Hello and welcome to this section of the Algebra Tutor. In this section we're going to continue learning how to factor, but we're going to kind of give you some extra tools in your tool bag for certain cases that help factoring become a little bit easier. I mean, you already know the basic idea of what factoring is. You have a big expression and you're trying to reach in there and pull things that are common from all the terms and sort of rewrite everything by pulling some stuff out and making that expression equal to the original expression, after you've done the factoring. We've talked about all that stuff before. Here we're going to talk about factoring by grouping. It's kind of one of those things, occasionally you come across a problem that will benefit by factoring by grouping, and then you can use it. So before we get to that point, let me go ahead and review a little bit of what factoring is, and then we'll show you how to apply factoring by grouping. And you'll see that it kind of depends on certain things happening for you to be able to do it. T squared minus 3t. Let's make it t squared plus 3t. This is sort of a review. In general, factoring is you want to go in and take something out that's common. So here we have a t squared and here we have a t. So we know that one t is common to each of these guys. So from the last section we learned we can pull that t out, and then on the inside we need to have another t, so these guys make t squared, and then we need to have a plus 3 here. So when you back multiply, you get everything back that you started with. So this is kind of a review. We've done this kind of problem before, but I'm just reminding you what factoring is all about. Now let me give you another problem that you haven't quite seen before. What if you have x plus y times 2 plus x plus y times b? Now this looks a whole lot different because I have a very large expression, and then on each one of these terms I have something in parentheses here and something in parentheses here. So at first I don't know what I can pull out because I have a 2 and a b. I do see some x's and some y's, but it looks totally different than any of the other problems that we've ever had to deal with. So at first you're unsure until you realize that here the term I have in parentheses is x plus y. Here, the term I have in parentheses is also x plus y. So what you're going to find out is that when you're factoring, you don't always have to just pull one item out like we've been doing. You can pull entire terms out as long as they're common to everything. So again, it's not a new rule of algebra. Factoring by grouping sounds like, another thing we have to learn in algebra. Oh no. No, it's the same thing that we've been doing. I'm just teaching you an expansion of it. You can go in here and recognize that x plus y is common over here. It's also common over here. So I can reach in and pull them out because they're common to both things. So when I do that, I'm going to do just like I do before. I'm going to pull x plus y out. I'm going to open a new set of parentheses, and I'm going to figure out what needs to go in here. And if you think about it for a minute, I think you'll agree that 2 plus b must be what is inside of there. And that is the factorization of this guy when you pull out the greatest common factor. So it's pretty easy when you look here and you say, okay, I can pull out a t, right? Or if you see some numbers and you can pull them out. But if you ever see a case where entire expression is common to both of these terms, then pull it out. And if you do the backwards multiplication, this times this gives me this times this gives me that. So it's all totally legal. These two things are exactly equivalent to one another. This is called factoring by grouping. It's because you kind of look at a group of terms and you try to find out if any groups are common and you pull it out. Now what if you had something like 3 times r minus 2s minus x times r minus 2s? So again, we're looking for groups of terms that are common. So immediately I see r minus 2s is common here, r minus 2s is common here. So at first glance you don't think you can do anything, but then you realize since this is common both places, I can actually pull out the whole darn thing, r minus 2s. And inside, all I'm going to be left with is 3 minus x. Because when I back multiply, this whole thing is multiplied by this to give me this. This whole thing is multiplied by this to give me this, right? So you're pulling it out and you're basically writing what's left over. And that's the final answer to this guy. Now what if you had 2x times a squared plus b plus 2y a squared plus b? So again, it's sort of like the same story, different verse. You can see that in this part of it, you have a squared plus b. You also have a squared plus b common to both. So you just pull the whole thing out. A squared plus b, open a parentheses, and you're basically writing down what's left over. I have a 2x left over here, I have a 2y left over here, and that's the final answer, because if you back multiply, this multiplied gives me this multiplied gives me this. All right, so let's expand this a little bit and say, what if I have 3x times a plus b plus c? And over here I have negative 2y, a plus b plus c. And I ask you, factor this or simplify this. Again, at first, before learning this, you might say, well, there's nothing to do. There's nothing common. But then you realize this entire term, a plus b plus c, is common to both of these larger terms. So I can just pull it out, just like anything else. A plus b plus c. And then what's left over here is 3x minus 2y. The minus sign comes from this minus sign, and this is the answer. So you have a plus b plus c, parentheses 3x minus 2y. And if you take this whole grouping and multiply by this, you get this. This whole grouping multiplied by this, you get this. So it's all self-consistent. So it's not really like it's a new rule. It's really just that you're learning how to use the general rule of factoring and applying it to something that's larger. So what if you have x plus 3 times x plus 1 minus y times x plus 1? All right. So it's the same thing. You're looking for groups of terms that are common, and you see right away x plus 1 is here, x plus 1 is here. So I just pull out x plus 1, and what I'm going to have left in the end of the day is this x plus 3 minus y, because this is all that's left. This is what's left over from this part, and this is what's left over from this part. And if you back multiply, you'll see this times this gives me this times this gives me this. So I'm done with that. All right, now let's do something a little bit different. Let's say we have 2x plus 2y plus ax plus ay. Now you look at this and you say, well, I don't have any group terms, so I can't really do that, but I do see that there are some things I can do. I see that there's a 2 common here, so I can pull that out. Let me pull that 2 out, and what I'll be left with is x plus y. We've done factoring enough where you should know that you pull the 2 out, what's left over is what goes on the inside. If you back multiply, you get what you started with. Over here I notice there's an a common, so I'll pull that a out, and again I'll have x plus y left over because those are the only things left over. So I think I'm done. I'm about to circle my answer, but then I notice, wait a minute, I have x plus y here grouped together, and I have x plus y here grouped together. So I can use factoring by grouping to just pull out the entire thing called x plus y. And what will I be left with? 2 from here plus a from here. Now, doesn't this look a whole lot simpler? I mean, this is what we started with, and this is what we ended with. You know, and if you go through and do FOIL here, like we know how to multiply these now, you do FOIL and everything, what you're going to end up with is all of these terms, which is what you exactly expect. All right, now let's say you have 2 times a times x plus 2 times b times x plus 3a plus 3b. And your job is to factor this as much as you possibly can. So there's no groupings, you can't look at groupings, but you notice right away that there's a 2 here and a 2 here. So let me pull this out. And I also know between these two terms they share an x. So let me pull the x out. So that's everything common. The only thing left over here is an a, and over here is a b, and the plus sign comes from here. So I have that. And then when I go over here, the only thing common here is 3. So I take a 3, pull it out. What's left over? A plus b. So I think I'm done. I'm about ready to circle my answer. And then I realize, wait a minute, I have an a plus b common here and an a plus b common here. So let me pull that whole expression out, a plus b. And on the inside, the only thing is going to be is what's left over, 2x plus 3. And this is the answer. And this looks a whole lot simpler than what you have over here. And if you were to take your time to do FOIL, first, inside, outside, last, you're going to get back what we started with. And if you think about it, the first terms, 2x times a, gives you this guy. The outside terms, a times 3, is this one here. The inside terms, b times 2x, is going to give you 2bx. And the last terms is 3b, which gives you the last one. So you can check everything once you factor. Just reverse multiply everything, and you really should always get back what you started. Otherwise, you made a mistake. So let's take one that's a little more complicated. X cubed times y minus x squared times y minus x times y squared plus y squared. Lots of x's, lots of y's running around. I don't see any grouping. There's nothing obvious that I can pull out, but I can see right away that, and there's, by the way, a lot of ways to do this problem, but if I look at the first two terms, I can see right away that I can pull out an x squared because I have an x squared here and an x cubed here. So I can pull out an x squared from these first two terms only, and when I do that, I'm going to be left with xy in the middle minus y, right? Because x squared times x is going to give me x cubed y, that makes sense, and then x squared y is going to come from there. And then from these last two terms, I'm going to pull out negative y squared because y squared is common to both. And so I pull out the negative version of it. On the inside, all I have is x, right? And then over here, I'm going to have minus 1. And the reason I have a minus 1 is because when you back multiply through, negative y squared x gives me this. Negative y squared times negative 1 gives me positive y squared. So I look at this and I don't think I've really made any progress. But then I realize that I kind of overlooked something to begin with. Over here, you know, I actually only pulled out x squared, but in reality I could have pulled out an extra y. And that actually happens sometimes. You look at expressions and you're like, I'm going to pull this out. And then when you're done, you're like, oh man, I could have pulled out some more stuff because you don't catch it all the first time. So this is an example of that. I only pulled out an x squared. I could have pulled out a y with it. So let me fix that now. Let me go ahead and just continue. I don't have to erase anything. I'll just continue on. X squared. Now I'll pull out the y from this guy. I'll be left with x minus 1. And when you think about it, I pulled the y out, so it disappears from here and it disappears from here. And if you back multiply, you're going to get back what we started with. So everything makes total sense. And then I'm left over here, y squared, x minus 1. I'm ready to circle my answer. And then I look and I say, wait a minute. I have x minus 1 common here and x minus 1 common over there. So I can pull out x minus 1 as an entire term. And what's going to be left over here is x squared times y. And what's going to be left here is negative y squared. All right? So I've basically done all the factoring by grouping I can. And you can stop here and almost circle your answer. But if you really want to get to the end game, you look here and you say, inside of here, I still have a y, and I still have a commonality with y in each place. I can pull out another y here. So I can just write that as x minus 1. Let me pull out another y. And on the inside here, if y is gone, all I'm going to have is x squared minus y. Right? X squared minus y, just like that. So I pulled this y out, I pulled this y out, and this is what was left. And this is the fully factored version. You can't factor anything else. There's nothing really common here, here, or here that I can really do. Now I want to stress that there was several times in that example when I pulled something out and then I realized later I could pull some more stuff out. It's very common and it's okay. You didn't make a mistake. It's just that after I pulled out the x squared here, in the next step I realized, oh, I could pull this out too. So then I go and do it in the next step. And then when I got done, I realized, oh, I could pull out another y here. So it's not that you have to erase your paper and go back and fix it. You just do it as you go and pull out things as necessary in order to get down to the final answer. All right, so here's a large problem. We have x squared plus xy plus x plus 2x plus 2y plus 2. And the question is, factor this expression as completely as you can. There's a million ways to go about it, but what I notice right away is that in these first three terms, there's an x common. There's an x here, and there's one of the x's wrapped into there. So let me pull out an x, and here I'm going to have an x left over there. I'm going to have a y left over from there, and I'm just going to have a 1 left over after I pull the x out from there. And if you back multiply, you'll see that everything equals what we started with. Now over here, I immediately see 2's everywhere. So I'm going to pull out a 2 from here, pull out a 2 from here, and when I pull this 2 out, I'm just left with 1. And if you back multiply there, you'll see that everything I did there was correct. Now, it jumps out at you that this giant grouping is the same as this one. So I can actually pull that out. X plus y plus 1. What's going to be left over here? The only thing left is x. The only thing left over there is 2. So you have x plus y plus 1 times x plus 2. And it's a great example of pulling out some initial things, and then after you pull it out, you see something large that's still common. Anytime you see something large, you can go ahead and pull that guy out. All right, we're winding our way down. What if we have a times d minus b times d minus c times d plus 3a minus 3b minus 3c? And the question is, factor this as completely as you can. And so there are lots of ways to go, but then you look at the first three terms. You see a d, and a d. So I'm definitely going to pull these d's out. What I'm left with here is a minus b minus c. That's what happens when I've factored that out. And then over here, I see 3's everywhere. So I'm going to pull this 3 out, and here I have a minus b minus c. And of course, especially constructed to show you that you have this giant term here and here that are both common. So I'm going to pull that entire thing out, a minus b minus c. What am I going to have left over here after I pull it out? I'm going to have a d plus, the only thing left over there is 3. So you have a minus b minus c times d plus 3. That's the final answer. So you pull one thing out. Sometimes you see groupings left over and you go for it. Now this will be the final question, practice question in this section. What if you have a times r squared minus b times r times s plus a times r times s minus br squared? And you want to factor that. Well, you know, there's a lot of things you could do here because, you know, you have an r here, r squared, there's an r, there's an r, there's an r squared. So you're tempted to just take the r and pull the r all the way out, and maybe you could do that. But when you play around with this enough, you'll start to see patterns. See, here's an r squared, and here's an r squared. So even though I could factor an r out of everything, I'm going to actually just not even deal with these here. I'm just going to pull an r squared out of this term and this term, because really you want to always try to pull out as much stuff as you can at any given time. So let me pull out an r squared like this. What's going to be left here is a, and over here is going to be left with minus b, because if you back multiply, you're going to get the negative br squared there, and so on. And so what I'm going to do is put a little dot on top of this and a dot on top of this to remind myself that I've already pulled stuff out of that, and I can ignore it for the rest of the problem. Now, we look at this and say, well, what can I pull out from here? I have an rs common and also an rs common. So I'm going to go ahead and pull out rs from both of those guys. Inside of here, the only thing left is going to be negative b. The only thing left here is going to be positive a, right? And so suddenly it doesn't look too helpful, but then you realize, okay, well, I can rewrite this. R squared a minus b plus rs. Negative b plus a is the same as a minus b. I think you would agree. I mean, I still have the a, positive a, I still have the negative b. It's just that I've rearranged the order of it, and that is the same exact thing. And when I do it that way, I see that a minus b is common with a minus b. So I can pull the whole thing out. A minus b, what's going to be left over here? I'm just going to have an r squared. What's going to be left over here? I'm just going to have an rs. And so that's basically common there. And then I think I'm done, and I basically am done, but I notice here that I could do a little bit more because I still have an r squared and an r, so I can pull an r out for those guys. So on the outside, I'm still going to have a minus b. Let me pull another r out. Inside, I'm going to have r plus s, because r times r is r squared, r times s is rs. There's nothing else to pull out. There's nothing to simplify or add or subtract, and that's it. So it's another example of, there's lots of different ways to go, but I knew that if I pulled r squared out of here, I would have something simple. And here I had the opportunity to pull two variables out at once, so I took it. And then once you get down to this point, you can see that these guys are common, so you can pull that out and then finish simplifying the answer. So factoring by grouping is not something you see all the time. It's not something that always lends itself to the problem. Most times you factor and you pull everything out, and then that's just what you have. But occasionally, when you pull things out, you'll see patterns in the results, that you maybe have some giant terms left over that you can pull the entire term out. And prior to watching this section, most people probably wouldn't think you could do that. But when you factor things out, you can factor anything out. You can factor entire expressions out as long as you're careful about making sure that you've done it correctly. So make sure that you can do all of these problems. Go work some extra problems in your book and in the worksheets. and then make sure you master everything and follow me to the next section where we're going to continue working with factoring.